a minute for people.
Very cool. What's the time in Indian time? 9 p.m., right? At the moment.
Yeah, right now it's 8 p.m.
8 p.m. All right. Sorry, guys, for making you come so late. I hope it's still interesting for you. If it makes you feel better, it's 6 a.m. where Patrick is, so he woke up real early to come and show up today.
Yeah.
Bright and bushy-eyed.
All right. I think we can start off now, and then we'll have more people joining in. So very glad to welcome Francesco and Patrick from Superfluid. And, Superfluid, the idea of streaming money is one of the more far out ideas out there, and that's only possible in DeFi. And, was really glad to see the things that were built last time, and looking forward to some cool hacks this time as well. And yeah, over to you, Francesco.
Right, thank you, Denver. It's a great honor to sponsor you guys again. So it's the second hackathon we sponsor with ETHOdyssey. As Denver was saying, the last one was a blast. There were some really great hacks, and I'm really looking forward to see what everybody cooks up this time as well. So let me tell you a bit about Superfluid, and then I'll pass it on to Patrick, who will give you a technical explanation. And I'm gonna just go through the presentation, and feel free to ask any questions in the chat. And after, I'll answer all of them in order, okay? So what is Superfluid? So Superfluid is digitally native programmable cash flows. So we are trying to make cash flows native to the blockchain so that we can transfer money on-chain in a recurring manner. So we call this streaming money. We transfer money every second, and we do it without locking the funds and allowing you as a developer to program these cash flows into your applications. So the reason we're building this is because we believe money is broken. So obviously, digital money works. We've all used online accounts, but it still doesn't feel the same way our internet feels, right? So when you sign up to a service online, you have a continuous relationship with that service. But for some reason, you're still paying it once a month. When you work with an employer, you're giving them your heart and soul. You're working, for days, and you get paid once a month. Now, why is that? We believe that is because our financial system is outdated and needs an update. So what we're doing at Superfluid is trying to upgrade that. So we believe that while the blockchain is a great way to move value, it's still not perfect. And by upgrading money, by building a new generation of money, we can create a more expressive money layer, enabling continuous cash flows that are simply not possible in traditional finance. Now, by building these perpetual money streams, we can create things that have never been built before. And basically, we believe we can leapfrog traditional finance. So what is money streaming? Money streaming is transferring money in a frictionless way from one account to another over time, creating an open-ended connection. So Superfluid streams are open-ended in the sense that they never stop. So if you open a stream, for example, I want to start paying Denver, $1 a month as a donation. As long as I always have funds in my account, that stream will continue forever. Now, as a user, you don't have to do anything. You simply post one transaction on chain, and that starts the stream. And this is great because it links the value transfer and the service provision very tightly, right? For every second that Denver behaves, I'm going to pay him. As soon as he starts not behaving properly, I can close that stream and we can sever that relationship. So as you can imagine, if this were a service, if this is your employer, they will always be paying you. They'll never delay the payment because they're paying you for every second you work, right? Which means you are never on the hook wondering if at the end of the month you will get paid. And this is great because it means you can potentially work for a company on the other side of the world without even knowing who it is. And you know that they're paying you. You never have to trust them. And that's one of the really cool things that streaming money enables. So how does Superfluid work? So the really cool thing with Superfluid is that as a user, you make one transaction on chain, and after that, your balance updates automatically. Now, the way we are able to update the balance automatically is by using the clock that's on the blockchain, right? The blockchain is basically a really secure clock. So we store some information about your stream, we check the current time, and we calculate your balance every second. So as time goes forward, your balance will also change. And this enables us to provide users with a great experience. They never have to touch their streams. They just have to make sure that their balance is never negative. Now, Superfluid works through super tokens. So obviously you can't stream DAI, right? Because the basic ERC20 doesn't have a stream function. So to do this, you have to first upgrade it to Super DAI. Now, when you have Super DAI, you can access the agreement library. And the agreement library gives you two different ways of transferring money. One is streaming money, so what I've been kind of describing so far. And the other is a way to transfer money from one account to any number of accounts in one single transaction. It's like a burst of money. So by creating a super token, you immediately get access to all of the agreements. Now, super tokens, you can create your own. So there's two ways. You either wrap an existing token. So for example, you take DAI and you create Super DAI, or you create your token from scratch using Superfluid. And we call that a native super token. So programmability is also a very important concept in Superfluid. You basically are able to create a smart contract that knows that it's receiving money every second. So it's not simply about moving money from A to B once and then doing things. It's about a smart contract that is receiving money on a continuous basis, right? So the stream has a life cycle. It starts, it can be updated, and it can be closed. And every time one of these things happens, you're able to react and trigger custom logic. And this is the core of how you can build really, really interesting applications using Superfluid that you will need for the bounties that we set out. So there's two ways you can interact with Superfluid. You're probably going to have to use both, or only the first one. So the first one is simply our JavaScript SDK. So if you're building a front end, you have a very simple way to open a stream. It's one line, Bob, flow, to Alice, a flow rate of X, right? That amount is how much you will transfer every second in that token. So it's just this one line, and you open a stream of money, which will go on forever. The other way is the Super App framework, which is what I was explaining before. And this is in Solidity, and it enables you to create these hooks when an agreement is created, updated, or terminated. So you can build this custom logic that enables more powerful apps. So if you want to have a feel of this, kind of experience money streaming, just go to our dashboard. It's app.superfluid.finance. And there you'll be able to immediately open streams on testnet or on Matic and just kind of experience this yourself, right? So you can use this throughout your hack, and it's a great way to see what's going on from your account. So for this hackathon, we have 3 prizes. The first one is for an application of streaming money and lending. So for example, I maybe want to take out a loan of $1,000 a month in a stream by putting up some collateral, right? So this is a very new concept. Nobody's built this before. So you would be the first to build a streaming lending application. The second one is for an application of streaming tokens with social tokens. Now, if you haven't heard of social tokens, just search it on Google. There's plenty of amazing, opinion pieces trying to explain that social tokens will be the next big thing. Now, we think they will be, but we think that they will only be the next big thing if we can stream them. So we're looking for an application of this. And the third prize, we call it the pirate prize. It's for anyone who builds something really cool that doesn't fit into the first two categories. So if you have a better idea, or if you want to check hack.superfluid.finance, you'll find a bunch of ideas. If any of those are good, just go for it, build it, and you will qualify for the third prize. So in any case, I invite everyone to go to hack.superfluid.finance. You'll find some ideas, you'll find some teams that are forming, and all the resources you need to start hacking, and the link to our Discord, which is the single best place to get in contact with us if you need any help. And without further ado, I'll leave it to Patrick.
Alrighty, thank you. So we're gonna jump now into the more gritty details. This is DeFi surfing. So we're going to learn to ride the wave now. We learned what Superfluid is. Now it's time to actually go into the water, jump on our board, and figure out how we're going to balance and ride this funny wave. All right, so as Fran mentioned, starting a flow is basically Alice.flow, Bob, and then a flow rate, right? But what's this flow rate thing, right? How do we calculate that? So that's like kind of what we're gonna talk about today, and then we're gonna talk about how to use the SDK and how to query data using the subgraph that we have, so that you can put together a whole application, a whole front-end application, and win one of these bounties. So the first thing, the SDK. We've got the link to this presentation in the chat right here, and then we'll put it in the description for the video as well. This presentation is a GitHub repo, basically. You can watch a previous recording of it, or if you click this link, hack on the presentation, it actually opens Gitpod, where you can see the code that I'm writing for the presentation. There's code in this. And then like deck.mdx is where all the details of the presentation. But then if it should automatically start a separate tab or a separate window, and you'll see this actual presentation. You can click through it and everything. Okay, so the link here is to the docs. It's basically just our doc site talking about how to use the SDK. You're just going to run yarn add or npm install, and then provide the SDK. And then you need to provide either Ethers library for contracts and providers, or Web3.js. You can use either one, but we recommend Ethers project. And then it's just a matter of importing the library, importing your Web3 provider, creating a new Superfluid framework object using that provider, and then calling the initialize function. And one thing to keep in mind is this is an asynchronous function. So you'll need to put that inside something that is async. And that's all you need. So then now you're ready to go. Now you're ready to rock. You can build a whole application that streams money using just this SDK. But if you want additional logic, you're going to have to do what Fran said, was build a super app and use those callbacks and all that stuff. But starting with SDK, we're going to start small here. So now that we have the SDK initialized, we want to open and close a stream. So what we'll need is the token that we want to stream, which you can get by going to the token list. And then you'll need a flow rate. And so here's just two more examples of what that would look like. So to create the Carol object, we're going to call sf.user. We're going to pass Carol's address and the token that we are interested in. So each user object is specific to a token. For now, we might change that in the future. And then once we have our object, then that's when we can go ahead and call the .flow function on our user object on Carol. And so now we're just saying, okay, Carol, we're going to flow, we're going to go to this recipient and this flow rate, which is 1,000 tokens per month. And you might be saying, okay, that's like a really confusing number. So we're going to figure out how we calculate these numbers. How do we calculate flow rate? So we're going to start out real simple. So in 1 minute, we have 60 seconds. And actually, before I get into this, so block time is in seconds. So the blockchain's internal clock that Fran was talking about is measured in seconds. And the tokens we have are measured with, usually they have 18 decimals. And so what we need to do is we need to figure out how to convert this large number of tokens. So if you say you have one ERC token, that usually means you have one with 18 zeros, because there's no decimals for ERC20s. There's just only additional zeros, and then you have to convert units and do all this fancy math. But just getting back to the idea here, so we have 60 seconds in 1 minute, and then in 1 hour we have 60 of those. In 1 day we have 24 of those. In 1 month we have 30 of those. And so if you create these constants in your application, then you can essentially say, okay, 1 token per hour is equal to 1 with 18 decimals. So 1 times 10 to the 18th divided by 1 hour, the constant that you just created earlier. So this is going to be useful when you go and you ask the user, hey, they're gonna enter how many tokens per month do they want to stream. You're going to need to come back and use this code to calculate what the flow rate would actually be. So if we run this here, 1 token per hour is 27777, this long number, and 1 token per month is this long number. So you can also check this, like if you're just like, did I do my math right? You can go over to the dashboard and do the send. We can type in fran.eth, or you can put any address in here. And then, like, what did I say, 1 per hour? Right, so this is adjusted for the 18 decimals, so it's a little confusing. But we see that this is 0.000277, whatever. So I think we're about right, and we can check this on our own. But this is like enough to get you started thinking about how to calculate flow rate. The other thing is, like, if you get tripped up by the units, you can click this link and go to the slitty documentation, which will explain why we have so many decimals and why we're using big numbers instead of what's it called, floating point. Okay, so we know how to open a flow. Now we know how to read data and like see what's going on with people's flows, right? So for instance, if you are going to build some kind of dashboard, like the app here, you would need to say, okay, does this wallet have any active flows right now? And so in order to do that, what we did is we created a subgraph for you to use, which is a handy tool that takes all this information and everything that's happening on the blockchain, on whatever network, and indexes it, which means it just kind of takes everything that happens and puts it into a database in an organized manner. So whenever someone opens a new flow, we take that little piece of data and we say, okay, let's create a new account, right? Let's track this user in our database, and let's assign this event, this creation of the flow, to this user. So now if I go and I query that user, I can just see, okay, here's all the flows that this user has open right now. And so that's really useful. And we call that process indexing, taking data from the blockchain, putting it into an organized and useful manner in a database. And this whole tool is called the subgraph. So in the subgraph, we can do things like query specific accounts. We can query flows, token events, and transactions. We can also query more token details, such as like how many users and how many flows are open for a specific token. So the link here is to the playground where you can start working with queries. If you're not familiar with GraphQL, I highly recommend you check out the section in the docs using this link, where I kind of give like an intro to GraphQL and like how you can learn how to write queries. It's pretty straightforward. There's a couple of tricks, but once you get the hang of those, you'll be making queries in no time, and feel free to jump in the Discord and I'll help you craft whichever queries you need. So in this example right here, we are asking for an account, and we're providing one argument. And that argument is, give me an account with an ID equal to this. And so this ID is someone's wallet address, right? So it's an account for this wallet address. And then in the body here, we're asking for flows owned, which is give me all the flows that are being sent from this person. So what flows do they own? We say owned because they're in control of the flow, basically, opening it or closing it or changing it. Not to say that somebody else couldn't close it, the receiver couldn't close it, but the owner is the person where the flow is originating from, and the receiver is the person receiving the flow. So we're saying for this account, say this is Alice, right? So for Alice, we just opened that flow in the previous slide. Now we're asking for data. We're saying, okay, right now, give me all the flows that she has open right now, and give me these certain properties about that. Give me the flow rate, give me the sum of tokens that have been flowed, give me the last time that it was updated, so at the last time this flow was changed, and give me the token details. And you don't need any fancy library to make a GraphQL query to actually perform the query. It's simply a web post request. So in this example, I'm just using Axios. You can use Fetch. You can use Apollo GraphQL in your front end, which is probably the most robust solution that you probably want to think about. But here, I'm just simply making a post request. And in the next slide, I've taken this code that you see here, and it's actually in a React component, and you'll see it appear here on the screen. So this is a React component that's in this repo, so you can fork this. You can go copy the code right now if you wanted to see how I'm doing this. But basically, I'm just doing the query from the previous slide and then putting it into this little JSON to table library that makes this nice little pretty table for us. So the query was, give me the flows owned. The first property that we wanted back was the flow rate, and we've got that. We wanted the last time it was updated, which is a timestamp. We've got the sum, which is 0, and we've got some details about the token. So this is ETHX. It looks to me like we're flowing at 1 per hour, which is what we talked about in the flow rate calculation slide. And like I said, you could just go grab this in this repo /components/GraphQuery, and you could see how to perform a query like this. There's a lot more nuances to that, but that's all I'm going to go into today for making queries. Next up, we're going to learn about how to calculate how much has flowed, because you might be asking yourself right now, you say, sum is 0. Wait, why is sum 0? Last update, was at least 1 second ago, right? Because if the flow rate is greater than 0, then that means we're actively flowing tokens. So we are going to go into our console and type new date, pass that in, gives 3 zeros to adjust for milliseconds. So the JavaScript date is in milliseconds, and the last update is in seconds. So that's just something to keep in mind. We need to add 3 zeros for milliseconds. So we can see here that in the console, this date was March 10th. So that was a while ago, right? So why is sum 0 here? Well, the reason is because, and I think next time I give this presentation, we're gonna add a little graphic here to explain. The reason is because because of the way we're doing this indexing. Okay, so data only enters our subgraph when a transaction is made, when an event is emitted from the contracts. So because this flow was opened and then no changes were made to it, the last time a change was made to it, the sum was 0. Alice flowed to Bob 0 tokens because this is the first time she's opening the flow. So Alice opened the flow, we're streaming to Bob, but no more events have occurred, which means our subgraph where we're storing this data has no way to update what's going on. This isn't to say that those tokens aren't flowing. So if Bob wants to go and check his balance, it's going to be correct. He's going to have the right amount of tokens in his wallet. Those tokens are flowing all the time. Like Fran said, you just open the one transaction and they're going, so you're good. But because this subgraph is a separate service, right? Like we can only update the state of the subgraph when events are emitted. So what that means is that you, as a developer, are going to have to figure out what the change since the most recent update is. So it's very simple calculation. All we're doing is we're taking the sum that we get back from the subgraph and adding to that the current flow rate times the difference in time, right? Because flow rate is tokens per second. So if we multiply by time, we remove the units of seconds and we just get tokens. So in this example, we're getting the date right now on line 1. We are calculating what 3 hours ago would look like. And that's going to be our last update time. So let's say Alice opened this flow 3 hours ago. And the sum is 0, right? So she just opened it. And then we have our flow rate like we found from the earlier calculations, which is 1 per hour. And so to get the total amount flowed, we're saying to give me the sum, add the flow rate times now minus the last update. And we see that that is 3 tokens because we're at 3 per hour and this was 3 hours ago. So this is how when you get the query back from the subgraph, you need to do this extra step to calculate the total sum. And just remember here that flow rate will be we got a question. Flow rate will be calculated in seconds. Can we define flow rate to be once in a day or so? Yeah, for sure. So back on the flow rate calculation page, you can use one day. So you would do const 1 day, 1 per day equals 1E18 divided by 1 day. And then we can see what that looks like. 1 per day. All right, so there's our 1 per day amount. Yeah, so you could come up with whatever flow rate you would like based, you could do some arbitrary, 1 per year or 1 every 3 months. Like it's totally up to you how to define flow rate. Let's see. Okay, back to. We've got calculating totals. Okay, so now we've opened the flow rate, or we've installed the SDK. We learned how to open a flow. We learned how to calculate flow rate. We learned how to make a query with subgraph to get data back to our application, and we learned how to adjust the sum of tokens and account for that difference between the current time and the last time the subgraph was updated. The last piece here is going to be representing this to the user. So for example, we have a stream details page that you can send to people and say, hey, here, look, I'm streaming you money. They can click the link, they can open it on their phone, they can open it on their desktop. And so the first thing you notice on the page is that there's action, right? There's activity. So this stream is alive, it's flowing right now, it's not static. There's movement of money from one account to the other. And that's important when you go to write your application. You don't want to show this number that's actually changing as a static value on your page. So I've included this component, this React component as well in the presentation. But essentially, we're just taking the amount of interest that's earned in 2 seconds, and then we are creating a use effect hook which updates the timer, which updates the count, and then we are displaying that count. And so you'll see here a couple things to keep in mind. If we just leave this number as is, we're going to get this really ugly string that just updates every 2 seconds. And actually, because it's not trimmed, it might even change in size, which makes the text jitter around on the page if the number changes the decimal places. So let's trim it, right? So let's make it smaller. Do we really care about 100,000th of a die token? Probably not, right? So we'll trim it down. We'll get it down to maybe 4 zeros or 4 decimal places. But this jumping every 2 seconds isn't very pleasing to look at. So we'll add this odometer JS library, which does this fancy scrolling. And so then we get to this final example down here. We've got commas, so people can see this large number and not be confused by how much it is. We've got our nice decimal place. We've got 4 decimals, and then we've got this nice animation. So you're welcome to use this in your application. Okay, so final slide, your adventure awaits. So what we talked about today was super tokens. We talked about streams, how those allow you to move money over time. 2 other things about super tokens that I want to point out that are just available to you to learn and ask questions about and to go beyond this presentation are ERC777. And this is a library that's native to every super token, and it allows your application to react when tokens are sent to it. And you can learn more there and then in our docs. And then there's batch calls as well, which allows you to send a bunch of transactions in at the same time. And that's a very helpful tool if you're trying to onboard a user quickly. You don't want them signing 10 transactions. You can just have them do everything in one single step, which is really nice. And so then once you've mastered super tokens, you have a grasp on how they work, then you can move into super apps, which is where you're defining your own custom logic, and you could do automated flows when certain things happen. You could do NFT stuff, games like lotteries and that sort of thing. So yeah, your adventure awaits. We're going to be in the Discord answering questions, and also here as well. I don't know how we're doing on time. I think we're a little bit over. Do we have time for questions?
No, we have time for questions. You can take your time.
All right, so we have one I see right now. Can I go ahead and update my flow rate at any point? Is that possible? Yes. So both the sender and the receiver can cancel the flow at any time, right? But only the sender, only the owner of the flow, Alice, can change the flow rate. So which is nice because you want all transactions to be push transactions in the sense that you're the one deciding what happens to your money. Somebody else can't pull money from your wallet. You have to push it to them. But if you say we're receiving money and you didn't want it, or you weren't supposed to be, or it was, I don't know, there's a lot of reasons why you might not want to receive money. you can cancel a stream that's coming to you. But you can't update their flow rate. So if someone's streaming you $100 a month, you can't magically turn it into $1,000 a month and pay yourself more. But certainly the owner of the stream can update it as much as they would like at any time, and set the flow rate that they would like. Any other questions? Is it possible to stream NFTs wrapped with super tokens? We've got this question so many times. I feel like it's for some reason it's where everyone's mind goes. Fran, do you want to take this one?
So I guess the question is, if you have one NFT and it's unique, right? There's one piece of something like an artwork or a CryptoKitty or a CryptoPunk. What does streaming mean, right? How can you move it over time? Now, one thing you can do is you can take the NFT, you can fractionalize it, and you can make the fractions super tokens, and then you can stream the fractions. So in that case, you know, I could say I'll give Patrick, I don't know, a CryptoPunk over a month. So I open the stream, and then at the end of the month, he's got enough of the fractions to redeem the NFT. That could be one way to do it. But you really need to be able to break something up into a lot of small pieces in order to stream it, right? That's kind of the basics. So first you have to figure that one out. But there's plenty of ways to do that. So if that's something you want to explore in the hackathon, you're welcome to do that. But just to remind you of our bounties. So we have streaming and lending. We have social tokens, and then pirate bounty for anything that you can come up with. All right. Does anybody else have any questions?
I think that's it for the questions for now, I think. But then, the Francesco and Patrick will be there in the Discord to answer more questions. And yeah, again, really looking forward to some cool stuff being built with Superfluid.
Absolutely. Wait, there's a
thanks everybody. Oh.
Sir, how can improve 2 days to $100,000? I don't know what you mean. I'm not sure. And Prince says, nice background. Yeah, it is. Unfortunately, this is not my place. I'm just borrowing it for today. But yeah, thank you, people.
You guys don't like my background?
All right.
Well, how about my t-shirt?
See everyone in the Discord. Join our Discord. We'll be doing our sessions, and next Thursday we have our community call if you want to come and join and see what other people have hacked recently on Superfluid.
All right. Well, I got a nice t-shirt.
Yeah, I think you got some love for your t-shirt. All right, folks. Thanks for joining in.
Thank you. Appreciate it.
Yeah.